To better understand recommended ways to handle air leakage, we'll look at why air leakage can occur, how to test for air leakage, possible consequences of air leaks, how to pinpoint the location of the leakage, how to assess the scope of the air leakage, and suggestions that our point here is that whether you look at the charging system, the primary or secondary service systems, or the parking system or other accessories, there's the possibility that you may find some air escaping from hoses, fittings, valves, brake chambers, and even major components like the compressor or a supply reservoir. It's already been suggested that some air leakage is acceptable by industry standards, but some causes of air leaks may call for further investigation or action. For example, an air leak can be caused by improperly installed components or loose parts like fittings and hoses. It can result from damage caused by accidents or on-road debris. It can be caused by extreme operating temperatures. It can also simply be that system components and devices have worn out and reached the end of their service life. But that end can also occur prematurely, when system maintenance isn't properly scheduled or performed, or if contaminants like dirt or nesting insects are present in the system. Do you always know if there is air leakage? Well, the indications can be very obvious, something you can see or hear. They can also be less obvious, like a driver's comment about how something feels. That's why checking for air leakage is a critical part of any pre-trip inspection. It's also recommended after any air brake system repairs or replacements, and it should definitely be part of regularly scheduled air brake system maintenance, along with draining the reservoirs and other procedures. You can learn more about proper system maintenance in other Bendix training materials. Testing for air leakage can be quick and efficient with what's known as the vehicle leak-down test. Performing this two-phase test can help identify issues that affect compressor wear and tear and system service life. The results are read using the dash gauges, and for more accurate readings, it's best for the vehicle to be at room temperature. The first phase is checking the air brake system with the service brakes released. With the parking brakes applied, charge the system to full pressure, that is to governor cutout. Wait at least 1 minute for the pressure to stabilize. Then start the actual 2-minute timing of the test. If during those 2 minutes the pressure drop for either service reservoir exceeds the acceptable pressure levels listed here, you'll need to investigate further to locate the actual air leakage source. Depending on what you find, you may need to repair or replace parts. You'll then need to retest to make sure you found the real cause of the pressure drop. The second phase of the test is checking the air brake system with the service brakes fully applied. Always chock the wheels first. Then charge the system to governor cutout. Release the parking brakes. Now, apply the vehicle service brakes using the pre-trip inspection system, if so equipped, or by using mechanical means, such as a block of wood, to maintain a steady brake application. Otherwise, you may get inaccurate results that lead to false conclusions. As with the previous test, let the pressure stabilize for 1 minute. Then, start the 2-minute timing. If the pressure drop is greater than the acceptable pressure levels listed here, it's time to check the components on this list. Repair or replace as necessary, and run the test again. Now, let's discuss possible consequences of air leakage. Truly excessive air leakage will obviously cause the vehicle to fail one or both phases of the vehicle leak-down test. Small to moderate leakage won't necessarily cause test failure, but depending on the location of the leak, the consequences can be considerable. And even if you don't see those consequences here, you could see them here. That's because brake inspections are an important part of the some 2 million roadside inspections conducted each year by highway patrols and and local law enforcement agencies.
If an inspector hears the hissing that indicates brake system air leakage, and if closer inspection reveals the leak to be in a hose or tubing, that vehicle will most likely be sidelined right then and there, and stay there until it's fixed. And that's more downtime, expenses, and headaches than anyone needs.
By now, you should see why knowing the right way to handle air leakage can be a bit of a challenge. On the one hand, large-sized leaks can cause excessive pressure drops, which, in turn, can affect system performance. On the other hand, audible air leakage from the hose, tubing, or chamber can sideline the vehicle even if the vehicle passes the leak-down test. In addition, you might be dealing with air leakage from other sources, say from fittings or valves. And depending on the possible cause of the leak, that type of leakage might call for everything from no action to a simple tightening, to a repair or replacement of system components. So since it's obvious that location and size both affect the course of action, we'll look at both concepts at the same time. The good news is you probably already have the recommended real-world tools for both. And whether you use a mechanic's stethoscope or a hose to pinpoint an audible leak, or a soap spray solution to find the source visually, you also need to know whether the leak you may find requires immediate corrective action. We'll start with some basic rules of thumb. First, if it's loose, tighten it. If it's obviously cracked, broken, or misinstalled, repair or replace it.
Repair or replace leaking tubing or hoses. Inspect braided steel Teflon air hoses using a soap solution, as leaks or cracks in these lines are hard to see or hear.
And if you're unsure about something, always refer to the service data sheets and vehicle service manual. To see how the rate of air leakage might affect your course of action, we'll use the controlled environment of the Bendix Engineering Lab and an instrument called a flow meter, which we'll use to measure air leakage in standard cubic centimeters per minute, or SCCMs. Let's consider how much air a Bendix 2-flow 550 compressor can produce. At idle, the compressor has an output of 3 standard cubic feet per minute. Translated into cubic centimeters, that's 85,000 SCCMs. Now, a soap spray solution can reveal air leakage as small as 3 SCCMs. But as you can see, that's all of about 0.003% of our compressor's idling output. Now, here's what air leakage looks like around 100 SCCMs, which, by the way, is well within the specs for valves in service. Whether an air leak of this size would call for further action might depend on the cause and/or the location, but it's definitely too small to cause leak-down test failure on its own. You'd still have to look for the primary leakage source. Now, here's some over-the-top leakage around 500 SCCMs. That's a quantity that could possibly cause leak-down test failure. And as you can see, the force of the escaping air blows the soap into larger bubbles, and the leak is now audible. There's one more visual indicator of possible air leakage: the presence of excessive oil on or dripping from the air valve exhaust ports. Some oil staining there is considered normal, since a functioning air compressor always passes a small amount of oil vapor, much of which is then removed by the air dryer. But excessive oil can mean troubles in the upstream portion of the air brake system. At the very least, it's a sign that system maintenance is overdue and needs to be done. Failure to do so can void the valve warranty.
When checking for leaks, be sure to include the vehicle's brake chambers and spring brake chambers. Check with a soap solution, and remember that minor leaks may be repaired simply by tightening the nut and bolt at the service diaphragm up to the torque spec published in the service data sheet. For Bendix brake actuators, leakage below 100 SCCM is acceptable. If you encounter a brake chamber that is leaking above 100 SCCM from around the service clamp band, replace the diaphragm and clean all parts. Leakage from the spring side of a spring brake chamber should be addressed by replacing the piggyback. Bendix piggyback replacement kits also include a new diaphragm service clamp band and hardware. Remember that air leaks add up to high-duty cycles for your air compressor, and that can lead to premature compressor wear and tear.
As our final topic, we'll talk about ways to improve overall air brake system health. The number one way, pay attention to anything that impacts the quality of air in the system. That includes regularly scheduled reservoir drains and air dryer cartridge replacements, regular pre-trip inspections. And be aware that open glad hands are an easy way for contaminants to enter the system. When it's not being used, close the coupling. The last way and best way to help ensure air quality? Make sure it's Bendix from the word go. Whether it's the power of having our dedicated service teams at your command or the value of having genuine Bendix parts in your hand.